Welcome to new session of the differential equation. In this session, we will discuss about the Bernoulli's differential equation. We already discussed about the linear differential equation. As we all know, the linear differential equation, first order linear ordinary differential equation is of the form y dash plus f of x into y is equal to r of x into y raised to n. This is what is called the Bernoulli's differential equation. From the linear differential equation, the only additional thing with it is that a y raised to n is there with a non-homogeneous part. Okay. Our thought is that how can we solve this Bernoulli's differential equation? We already discussed many methods to solve first order differential equation. Among that, one of the method is first order linear differential equation, and we discussed how to solve the first order linear differential equation. Now see, here we have f of x and g of r of x are here. This f of x and r of x are any real function, any functions in x alone or constants, any functions in x alone or constants. See, here we have one more thing with it is that a y raised to n. In y raised to n, the n may be any of the real number. So, we can take here n may be any real number. N may be any real number, not need to be an integer or a positive integer. That can take any of the real number as its value. See, our thought is that how can we solve Bernoulli's differential equation? So, here one thing is that we have y raised to n with a non-homogeneous part. So, we divide 1 throughout with y raised to n. So, nextly divide 1 with a y raised to n. So, we will have see y dash 1 by y raised to n into y dash. Therefore, this is equal to 1 by y raised to n into y dash. Say f of x into y, that is equal to f of x into y divided by plus f of x into y divided by y raised to n, and finally here we have r of x into y raised to n divided by y raised to n. Simply we can say that is r of x itself. So, this is equal to r of x. So, we can rewrite this as y raised to minus n into y dash plus f of x into y raised to here we have y raised to 1 is there, here we have y raised to n is there. We just take this y raised to n into numerator. So, we will have y raised to minus n, therefore, we have y raised to 1 minus n. See, this is equal to r of x. This is our second equation. See, dear students, now we changed our equation 1 into a little bit complicated equation. While seeing itself, we understood it is that this is not a linear equation. This is any kind of the differential first order linear differential equation. This is not any kind of the equation that we just discussed any of the previous sessions. So, we have to develop a new method. Our thought is that how we able to change this equation as a linear differential equation. So, for that I would like to change, I would like to give a substitution for y raised to 1 minus n. That is the term with the function f of x. So, I would like to put z equal to y raised to 1 minus n. So, we can just differentiate this one. So, we will have this is equal to, instead of this we can differentiate dz divided by dx is equal to, we can differentiate this side, that is equal to 1 minus n into y raised to 1 minus n minus 1 into dy by dx is there. Okay, into dy by dx is there. Say here we have dz by dx is equal to 1 minus n into y raised to 1 minus n minus 1. We can cancel plus 1 and minus 1, and finally there it remains a minus n only, and dy by dx is here, and a dy by dx is here. See, my dear students, we have dz divided by dx is equal to 1 minus n into y raised to minus n into dy by dx. Say, I would like to take this 1 minus n to here. Therefore, finally, we will have 1 by 1 minus n is equal to y raised to minus n into dy by dx, or simply we can say y dash dy by dx, or simply we can say this is y dash. See, we can come back to our original differential equation. In our original differential equation, we have y raised to minus n into y dash, that is y raised to minus n into dy by dx, that we found here y raised to minus n into dy by dx is equal to 1 by 1 minus, sorry, have just done a mistake here. It is that this is actually 1 by, see, 1 by 1 minus n into dz by dx. Okay, fine. Okay, this is actually y raised to minus n into dy by dx. So, the equation will become, we put 2. So, equation 2 becomes as, equation 2 becomes as, equation 2 becomes as, equation 2 instead of y raised to minus n into dy by dx, we just replace 1 by 1 minus n into dz by dx. So, 1 by 1 minus n into dz by dx, 1 by 1 minus n into dz divided by dx, 1 by 1 minus n into dz divided by dx. Okay. Then in the next part, f of x into y raised to 1 minus n. So, f of x into y raised to 1 minus n is z. So, plus f of x into z, and finally, we will have here it is that r of x. So, then r of x is there, is equal to r of x. Okay. See this differential equation, and while seeing, we feel that may be linear. The thing is that the who create the a little bit problem or confusion is that 1 minus n. So, I just put this as equation number 3 multiply 3 with 1 minus n. So, this implies finally we will have, this is dz divided by dx plus 1 minus n into f of x into z, and finally here it is equal to r of x into 1 minus n. See the equation number 4. While watching the equation 4, it is clear that this is actually dz by dx, as we discussed before, dy by dx, the first derivative, and there is a function and constant is there, there is a function and constant is there, and there is a the term of z is there, and also there is a non-homogeneous part. So, I can take this as a sum g of x and this as sum h of x, no problem. The equation has dz by dx plus some g of x into z is equal to some h of x. So, this is a kind of a linear equation. So, we can say that this is linear, first order linear ordinary differential equation in z and x, sorry, in z and x. Okay. So, we can say this is a first order linear differential equation in z and x. So, we can solve this equation as we done before. Any of the method, we just discussed two methods to solve linear differential equation. One is normal method, another one is method of variation of parameters. Any of the method we can use, you will get a solution in z and x. After that, you can replace z by y raised to 1 minus n, and finally, we will get solution in x and y. That is the solution of the Bernoulli's differential equation. A differential equation of the form y dash plus f of x into y is equal to r of x into y raised to n is the Bernoulli's differential equation, and finally, we will get the solution of the Bernoulli's differential equation. Okay. This is the method to solve, this is the way how to solve the Bernoulli's differential equation. Now, we can just move to the question. See, solve x into dy by dx plus y, x into dy by dx plus y is equal to xy cube Okay. Firstly, we can make it as dy by dx. We can start with the dy by dx or y dash. So, I would like to put this as equation number 1. Just we can divide 1 with x. So, this implies we will have dy by dx is there. While dividing with x, x will go on, and next term is 1 by x into y. Okay. The last term is x by x will be 1 is there and y cube is there. Okay. Fine. While evaluating this equation 2, we understood it is that is Bernoulli's equation. In Bernoulli's equation, we will have here this f of x is equal to 1 by x, and there is a term that is absent here, that is r of x, that is 1, r of x is equal to 1. The power of y, that is here, it is y cube is there. So, we will divide, as because while evaluating this we understood it is that this is Bernoulli's equation. As because that is a Bernoulli's equation, we have to divide throughout with the power of the y, which is belongs with the non-homogeneous part. So, we will divide with y cube, to divide with y cube. So, we will have this is equal to, while dividing 2 with y cube, 1 by y cube dy by dx, 1 by y cube into dy by dx, 1 by y cube into dy by dx, and 1 by x into y divided by y cube, 1 by x into y divided by y cube, and finally, we will have y cube by y cube, that is 1 itself, that r of x remains there, here r of x is 1. So, we have y raised to minus 3 into dy by dx, y raised to minus 3 into dy by dx, and 1 by x into y divided by y cube is y square is there, y divided by y square is there. While taking y square to numerator, y raised to minus 2 is there. So, y raised to minus 2. So, y raised to minus 2 is equal to 1. This is our equation number 2. Sorry, this is our equation number 3. This is our equation number 3. Okay, fine. Now, this is the equation that we generated an equation. We will feel a little complication on that equation, because it is Bernoulli's equation. We can just apply, we can put z equal to y raised to minus 2 as z, y raised to minus 2 as z. Okay. So, put y raised to minus 2 as z, put z is equal to y raised to minus 2. So, we can differentiate. differentiate both sides, therefore we will have dz by dx is equal to minus 2y raised to minus 2 minus 1, y raised to minus 2 minus 1. So, we found it is that dz so into because it is a term in y, dy by dx is there, that is y dash is there. Dz by dx and 1 by minus 2 is here, and we will have here it is equal to y raised to minus 3 into dy by dx. Fine, come back to equations. We will have y raised to minus 3. In equation 3, we will have y raised to minus 3 into dy by dx. Y raised to minus 3 into dy by dx is equal to minus 1 by 2 dz by dx. So, here we will have equation 3 becomes as equation 3 becomes as that is equal to y raised to minus 3 into dy minus 1 by 2 dz divided by dx. Again we will have 1 by x into y raised to minus 2. Y raised to minus 2 is z, 1 by x into z plus 1 by x into z. And finally, the the homogeneous non-homogeneous part, that it remains as 1. Therefore, here it is equal to 1. Okay, fine. This is the fourth equation. I would like to change this as will multiply with minus 2. This is the fourth equation. We will multiply 4 with minus 2. See, my dear students, multiply 4 with minus 2 implies, see, while multiplying 4 with minus 2, we will have minus 2 into 1 by 2 will be equal to dz by dx. Therefore, we will have dz by dx and minus 2 by x into z, minus 2 by x, minus 2 by x into z, and then finally, we will multiply this with minus 2. Instead of 1, there will be the value minus 2 is there, is equal to minus 2. This is the fifth equation. The fifth equation is the equivalent linear equation for the equation 1. So, fifth equation is equivalent linear equation for differential equation 1, that is Bernoulli's differential equation 1. So, now we can solve this one. So, while solving this, we will have here it is the term is there, f of x is there, that we discussed before itself. This is the term, f of x is there, and this we will treat as r of x. Okay, that we will treat as r of x. See, my dear students, we can solve by using the equation z into general solution of 5 can find by using the formula general solution of 5 can be found by using the formula z into integrating factor is equal to integral of integrating factor into r of x dx plus the constant of integration is there. Okay, now we have to find out the integrating factor. To find the integrating factor, if is equal to e raised to integral of f of x dx, that is equal to e raised to integral of the f of x is here. We will have f of x. See, f of x is here, that is the minus 2 by x. So, this is equal to e raised to minus 2 by x dx. Okay, So this is equal to e raised to minus 2 into integral of 1 by x dx is equal to e raised to minus 2 log mod x, that is log x, is equal to e raised to log of x raised to minus 2, and e and log is there, that will go on. Finally, we will have x raised to minus 3 is there, that is equal to, finally we can say that this is equal to 1 by x square. Even if we take the modulus, while taking the x square, all will be positive, therefore there is no relevance for the modulus there. Okay. So this is equal to, integrating factor is equal to 1 by x square. Therefore the general solution is, therefore to find general solution, z into integrating factor is 1 by x square is equal to integral of integrating factor 1 by x, sorry, integral of integrating factor 1 by x square into integral of integrating factor into r of x is equal to minus 2. Therefore this is equal to minus 2 dx plus c, the constant of integration is there. And here we will have integral of minus 2 is here, minus 2 x raised to minus 2 dx plus constant of integration. Here we will have z by x square is there. Okay. We have this is equal to minus 2 x raised to minus 2 plus 1 divided by minus 2 plus 1 plus the constant of integration is there. In left hand side there will be z by x square is there, and here we will have the minus 2 into x raised to minus 2 plus 1, that is x raised to minus 1 by minus 1 plus c, the constant of integration. In LHS we will, sorry, in LHS we will have z by x square is there. Fine. Okay. Z by x square is equal to minus and minus will cancel, minus 2 into x raised to minus 1. So we will have z is equal to, we can take the x square to here. So we have negative and negative will cancel, plus 2 is there, x raised to minus 1 into x square, that is equal to x. So 2x plus cx square is there, 2x plus cx square is there, plus cx square is there. So this is the general solution for cx square is there. If it is initial value problem, we are able to find the particular value for c, on that case we will get a particular solution. But here this is the general solution for differential equation, where that is the differential equation in z, that is the equation number 5. So this is the general solution for the differential equation 5. Differential equation 5. Now we can replace the value of z. Replace z by, see the substitution for z is given by s is, it is that the value y raised to minus 2. Okay. Z equal to y raised to minus 2. So we can replace z by y raised to minus 2. We can replace z by y raised to minus 2. Sorry, z by y raised to minus 2. So y raised to minus 2 is equal to 2x plus cx square. Okay. So y square is equal to 1 by 2x plus cx square is there. So we took reciprocal on both sides. Now this is enough, we can stop here. See, if we need, okay, if we need y square is equal to 1 by 2x plus cx square. Maybe y is equal to 1 by square root of 2x plus cx square is there, is the general solution for, is the general solution, sorry, general solution for Bernoulli's differential equation 1. This is a required solution that we are seeking. Okay, my dear students, this is the method to solve the Bernoulli's differential equation. We just evaluate which is the term of power of y that is with our this one non-homogeneous part. Here we have y cube is there, we divide the equation with y cube. So, we got a differential equation of the type of the equation number 3. After getting that one, we substitute with this one y raised to minus 2 as z. By that substitution, by differentiating both sides, we will get a differential equation in z and x. That differential equation in z and x is linear differential equation that can be solved by using the formula that we used in the solution for finding the general solution of the linear differential equation. So, we can find the integrating factor, and we can apply that integrating factor in the solution form, then we will get the general solution. After getting the general solution in z and x, we just replace the substitution of the value of the z, and then we will get the general solution of the Bernoulli's differential equation. Okay. Dear students, there are many questions and interesting questions you can find related to Bernoulli's equation. You may write down some assignments. Solve the differential equation, solve the differential equation x into dy by dx, x into dy by dx plus y is equal to x square y square log x, plus y is equal to x square y square log x. See, my dear students, here we have the power of y with the non-homogeneous part with the RHS is y square, divide throughout with y square. You will get a new type of the differential equation that you can convert into linear equation, then you can solve it as we solved linear differential equation. See, x into dy by dx, solve x into dy by dx, x into dy by dx plus y is equal to x cube into y raised to 6, y raised to 6 plus y is equal to x cube into y raised to 6. Okay. You can find many questions on the Bernoulli's equation. Try to solve the different types of the differential equation in Bernoulli's equation. That will give you much motivation on the differential equation. Thank you for watching these videos. Thank you very much.